Hello everyone, welcome again in a new tutorial. So today we will learn about pointers. I'm sure a lot of you guys have heard about it or even learned about pointers, but not 100% understand what is the main concept of the pointers. Okay, so today we will discuss about them in C++. So overall, the pointers are method that we use to optimize the code and also optimize the usage of memory. Okay, so from my experience, I can say that the best way to understand pointers is by taking some examples, because let me take the pen. Okay, so the best way of understanding the pointers by taking examples. Otherwise, if we just keep talking about pointers, that they're pointing to a data inside the SRAM, so it won't be clear to you guys. So I will make use in this tutorial a lot of examples to explain about the pointers. I will be focusing in Arduino Uno, that is based on this MCU, ATMEGA 328P. Okay, so this is a general chart that representing the pointers, that the pointer got an address and there's a value that's been held inside the pointer, and the pointer is pointing to this pointer is just pointing to the address of another memory cell, if we can consider this as a memory cell. Okay, so this memory cell that it holds the pointer that pointing to another memory cell, that it has the final variable value. Okay, I'm sure it looks like rocket science to you guys, but believe me, at the end of the day you will find it very easy. So I'm sure many of you guys, when you read this instruction, might find it very hard to digest, but wait and see until the end of the tutorial. Okay, so let's move on. So as I say just now, we are focusing on this MCU, on the ATMEGA 328. So this MCU has an SRAM. This is the screenshot from the datasheet, MCU datasheet. It has program memory, or SRAM, static memory of 2000 bytes. Okay, that start from 100 until 0x08ff. Okay, so this is the range of the program memory that we will store our variable in the code when we develop our code. Okay, so next, okay, so as we know, since we have 2 kilobytes of memory, so the memory locations will be start from 100 in hexadecimal all the way to 08ff. Okay, every cell of this memory consider of 1 byte, which is 8-bit. So we assume if it's not set to any variable, we assume here that we have 8 zeros. Okay, all 8 zeros. Each memory location, okay, got memory address and also got the value that's been assigned to the variable that we are declaring, and also we have the variable name. Okay, so in the future, in the next, we will see how we can fill in this information, how to make use of this memory map. Okay, but the thing is, we have to understand that this MCU or any other MCU, they have X amount of memory or RAM. Each location got 1 byte, and this 1 byte got address, assigned value of the variable and the variable name. Okay. So before we start into the coding, we need to go through and understand the variable size in the this C+ of the Arduino. So for the integer, if you see here, this is the reference page of the this data type variable. So for the integer, it needs to be stored as 2 bytes. Okay. For the bytes, it's just 1 byte or 8-bit. Float, this is very important. We will talk a lot about the float. It will be stored as 4 bytes. Okay. Character, only 8-bit, as you can see here. And for the string, actually, they are considering the string is just a group or array of characters. And at the end, we have a terminator. Okay, so string, it depends how long is your string, but we can consider it as a group or array of character. Okay, a group of characters. So these are the most important variables that we might use. Okay, it is very important that we not memorize but understand this data size of each data type. Okay, so here I have developed very simple declaration of the variable. So first of all, I have integer x equal to 10. When we jot down this in our code, the compiler will come and interpret each one of them. So when it comes to see integer x equal to 10, it means it will come to the memory location. Since this is the first one, so it will come to the first memory location. From the first memory location, since it is integer, you see, oh, here we have integer. So it will go back to check integer, how many bytes we need to allocate. Okay, 2 bytes. 2 bytes. Then they say, okay, we will take these 2 bytes and assign them under the name of x with the value of 10. Okay, now we have the next instruction, we have float. They say, oh, okay, since we have float, if we go back, we see float actually is a 4 bytes. So since the 4 bytes, then the float will take or will reserve 4 bytes, okay, with the variable name of g and store the value inside. Definitely, this value will not be stored as it is. It will be stored in a binary form, okay, 0, 1. But this one just to make it easy for you guys, okay. But in the actual saving will be stored as a 0, 1. Okay, and so on and so forth. When come to the byte, since it's a byte, it's just a 1 byte, so it will take only 1 byte of this variable, which is named d, and store number 12. Same goes to a, since it's a character, it will take only 1 byte. So, okay, now we come to the string. Focus on the string. Since the string, we said before that the string actually is an array of characters. So it will come to the string. They say, okay, for the string, we need to see how many characters do you have in your string. We have 1, 2, 3, 4, 5. So since 5 plus, we need to remember, we need to add a null terminator. This is another byte. Okay, so 1, H, 2, 3, 4, 5, 6. So that will take 6 bytes from here. Not easy to highlight, but it's okay. So take this 6. Okay, take 6 bytes for the H, E, L, L, O, and the terminator. Okay, so this is how it will be stored. And for sure, for the character and the string, again, it won't be stored as an alphabet, but it will be stored as an ASCII code instead in the binary. Okay, so this is how the compiler will deal with the variable declaration. So from here, can you imagine if, let's say, you have a lot of strings, okay, and these strings you need to process them. For example, you need to copy or you need to do some process on this string. Later on, we will see this thing will be copied many times. That will consume a lot of memory. And as we know, okay, as we know, we can see here the memory is very limited to 2K only. Cannot extend, cannot have more. Only 2K. So how we can write our code efficiently to fit in this 2 kilobyte of SRAM and no need any extra modules. Okay. So later on, we will see with examples how we can simulate an issues and also how we're going to solve them. Okay, so let's move on to the Excel sheet first to have an idea, then later we go for coding. Wait for it. Okay, welcome back. So now we just refresh back of what we talked before. So we assume this is our memory map, and this is our initial code where we identify and declare our variables. Okay, for example, here we have variable named X with value 10, and as we say, since integer it takes 2 bytes with the value 10. We have float G that will consume 4 bytes of our memory. Character will be 1 byte. Sorry, the byte will be, as it says, is a byte. Character, a byte also, and a string will take, we'll consider as an array or group of characters, and it will be as long as the string it is. Okay, so just to recap, each of these identifiers or variable, let's say the X, G, D, A, and S, actually they are by itself are pointers to the first memory location of each variable. For example, the X here is the pointer to memory number 0x0100. Okay? And from the integer, the compiler will know, oh, okay, this one is mean I have to read 2 bytes after the memory location or start from the memory location 100. So it will take 100, 101 and take the read of X. Same to the floating G. When the compiler see there is a float before G, then it will say, okay, the G is pointing to 102. And since we have float, it means I have to take 4 bytes starting from 102. So it will read this memory location. And so on all the way to string. When you see there are string, they say, oh, okay, I have to read as much as characters are there starting from S location, which S location, it will be start from 108 and will stop until reach the terminal character. Okay, so this is how the data of variable will be organized inside the memory map. Okay, so now let's take some example. Let's take out, or no, to take out, we just add, yeah, here. For example, we will declare another float, float n, just float n, no need to declare anything. And here we will have a condition if, let's say, how can I say, if the signal, or not a signal, just take the condition that we have. If x more than 0, then it will do this. If x more than 0, for example, n equal to g, and let's put the close bracket here, else, and declare another float, let's say here, float m, okay, else m equal to g. Okay, we have this code. Okay, if x more than 0, this will be executed, else this one will be executed. So when we run the compiler again, the compiler will arrange and allocate the memory for all these variables. This one we already allocated, then we come, there's a float n, they say, oh, okay, we have float n, it will find a place, for instance, is float. Let's say we take these 4 places, we can say reserve this for n, and since n got nothing, so it just will be reserved as empty. Oh, there's another float, it will take another 4 bytes, 2, 3, 4 as m, and again it's empty. Okay, so we can see here, we already reserved another 4 or 8, actually 8 memory locations for nothing, or consider wasted. Why? Because actually from here, from the code, we are still referring to the same variable. For example, if x more than 0, yes, x equal to 10, more than 0, so n equal to g. So this value here will be equal to g, which is 3.14. Sorry. Okay, so as we say, for some reason we might need to do this kind of code, that if x more than 0, n equal to g, else m equal to g. So since here in our code, yes, x is equal to 10, more than 0, so n will be same like the g, which is 3.14. Okay. So from here we can see, here we have only a few variables, which is just one string and about 3 or 4 this floats. So can you imagine if we have more and more variables, and our RAM will be building up more and more, and will be not enough to hold all our variables. So it's very good practice to keep monitor our RAM and make our code as efficient as possible, and take care of the RAM utilizations. Okay, this is one of the issues that the pointer might help in this. At the same time, can you imagine if we have image array? This is an image array, okay, that we might need to display any image or pictures on the GLCD, graphical liquid crystal display. So it will be in this format. This is, I believe, is the smallest picture. I believe it's less than about few tens of pixels. Okay, you see how many memory location. Okay, you see now 1, 2, 3, 4, 5, 6, 7, 8, 9, about 10 by almost I can say 100 memory location. If we do the same practice by keep copying the memory location or keep copying the variable to another place and keep making new copy of this image, then our memory definitely will not be enough to hold all our variables. Okay. So it's very good practice to use pointers. So for example, in this case, if you want to change to a pointer, instead of we use this, we can define n and m instead of floats, where they will take about 8 bytes. We can define them as a pointers. For example, it will be like this. So this is the bad example here, and here we will add the suggested example. No fill. So here we will have float, pointer n, and for sure pointer m. And for sure this is not the exact syntax, the correct one. This is just for example to understand the idea. So we have pointer n, pointer m. Okay, and since they have 2 pointers, or I mean the pointer overall will take about 2 bytes. So this one will be deleted. Go back to the original, delete, go back to the original, and this one also. Okay, so since we have n, so here we will have n, and here we will have m. Okay, so now these two, we can use them to point. So n equal to the, let's say, location of G, or m equal to location of G. Okay, so with this, if x more than 0, so n will hold the location of G. So the location of G, we know that G is start from this 102. So n will be equal to, since it's 2 bytes, so n will be equal to 0x0102. Okay, so n will be holding the first address of the the variable that we want to point to or refer to. Okay, but for sure this is not the exact final coding. This is just to give you an idea. So later on, this one will be referring, for example, if n come, then n will be referring to the location of G only. So it will hold, okay, now hold the location of G. So the compiler can go back to this memory location. They say, oh, I have 102. The address of the memory location should be 102. We'll go to 102 and continue read the G variable from there. No need to take a complete copy and waste about 4 bytes for each one of them, which will be 8 bytes. Same goes to here. We need to define only about 2 bytes pointer that can hold or represent the whole length of this variable. Okay, this is one example that we can use the pointer. Another very good example is when we are using like the EEPROM, we are saving any data to the EEPROM of the Arduino. I have screenshot this just now. This one if you want to write or read any value to the EEPROM, we need address and the value. We're more concerned now about the value. If you see the value here, can this address or the Arduino, the EEPROM overall can hold a maximum of a byte. Okay, so every write can be support maximum of 1 byte per location. So if I have only 1 byte, how can I store an integer? Let's say I have integer x equal to 10 or not 10, let's say 1000. This is 1000. Okay, how can I store this 1000 in the EEPROM, but the maximum EEPROM can store from 0 to 255? Okay, definitely cannot use directly the store. That's why, and this is the main point where we will use pointers to point each location of this variable. We'll consider as a byte. Then we store this byte in the memory location. We store this byte in the in the EEPROM location, and then we can successfully store the data. Okay. Same goes to the this pointer. Same goes to the float. If let's say I have float which is even bigger than the integer, which is 4 bytes. 4 bytes, I need to store it in the EEPROM, or not even EEPROM. Let's say I want to send to the I2C device, or I want to send over SPI to another MCU. Most of these protocols supports 1 byte per transmission. So how can I send a float, or even I send integer or even string or bigger variable over these protocols? Then we will use the pointers to make our life easy and also make our program very efficient. Okay, so that's all for the pointers. So we will, I'm not sure we see how long our video so far. If it's long already, I might make it in another video. If not, we will go directly to the Arduino IDE and we start to do some coding and we learn how to implement the pointer in the Arduino IDE. Stay tuned.